Okay, here we go, kiddos. Here's your help videos, summer school, semester 1 for topic 1 test. This is going to be the first couple questions. So first concept is the sum of 3 consecutive integers. You're trying to write an equation and solve. I've written down part of the equation here so far. The key to this one is if you figure out we don't know what the integer is, I'm just going to say it's a variable, but the next consecutive integers, you just add 1 and add 2. And then if I write those 3 next to each other and set it equal to 198, I have this nice easy equation to collect like terms and solve. Let's see, I've got 3 x's, and plus 1 plus 2 is plus 3, and that's going to equal 198. And you can finish that up and solve the rest of that question. That's the concept for that type of question. Okay, what happens next is if you're solving an equation that has fractions in it. Now you have to multiply by, in this case, 9. This is going to be the least common or the greatest common factor for the denominators. When you multiply by 9, you're going to multiply by this fraction times everything in the whole equation. So let's see here. This 9 cancels with that one, so this leaves 5x here. This 3 goes into the 9 3 times, so we're left with a 3 times this 1, so it's 5x minus 3. And over here we have this 3 times this 9 equals 27. See, if you multiply by a number, it cancels out the fractions and it leaves you with an equation that's much easier to solve. So you guys can solve the rest of that one. Okay, let's keep going up here. The next concept is about no solutions or infinite solutions. Okay, if when you're solving it and you get something that's impossible, it's something that's impossible. 3 is never going to equal 5. That's going to mean no solutions. If you come down to some kind of identity, any kind of 0 equals 0, or if you get x equals x, then that means infinite solutions. So they want you to fill in this blank right here to see what the missing value is for A, B, and C. So this is the setup when you try this on Savvis Realize for the topic review. I just decided to make that a variable. So I'm going to distribute and solve for y and to see which one of these has one solution, no solution, or identity. Okay, so if we distribute this, we get negative 4x, watch the negative, and then a negative times a negative. Oh, by the way, you distribute, you multiply that one times that one, and that one times that one. We can't forget that. So that'll make this plus 2y, which is a number, which we're going to add to 1, and that equals 17 minus 4x. Okay, so the question, what happens is when I add this 4x to both sides, look what happens to the x's. They wipe out. So I'm left with 2y plus 1 equals 17. Let me change the color. Subtract 1 from both sides, and you get 2y equals 16. Divide by 2, and we get y equals 8. Now, that means if y was the number 8, you'd end up right here with an identity. 8 equals 8. Okay? And that would mean infinite solutions. If y is anything other than 8, you're going to get something that's impossible, and you have no solutions. Okay? One more question for this first video, so the video doesn't go too long. Here we have where you actually have to distribute and collect like terms. You know, this is standard math stuff right here. I've done the first couple of steps. Let me show you just some stuff to help you out with collecting like terms. You might want to use underlines or colors like I'm doing. So I've got numbers there and there. So it's going to be 4x. Let's see, negative 20 plus 9 is negative 11. And here I've got, use a different color, a 2x plus 2x. So it's 4x minus 6. Uh-oh, this is what happens. This is what they're going to try to trick you on. If you get 4x and 4x, same sign, same number, same variable on both sides, they're going to cancel out like this. Say they both cancel out, and you get, again, here's this impossibility. Negative 11 is never going to be equaling 6. So I'm pretty sure that one's no solution. Make sure your question is the same. Okay, that'll be it for this video, and I'll make others here shortly.